All right, number 5. I'm just going to jump right into it. So I'm not going to reorganize it. I'm not going to find the rational zeros. I'm just going to use the calculator, and I'm going to graph it and find the zeros and then verify it with synthetic division. So I'm going to go to y equal. I'm going to clear out what I have, and I'm just going to type this just as it is. X to the third plus 24 minus 6x minus 4x squared. I'm going to graph it. All right, so 1, 2, it looked like that went halfway between. That doesn't look like a whole number. So then over here we got 1, 2, looks like halfway between, 3, looks like maybe 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So that would be 4. So we're going to try 4 and see if 4 works. And then from there we'll do quadratic formula or factor. So I will need to put it in order when I write it down, though. So I'm going to write x cubed, that's my biggest degree, and then minus 4x squared, and then minus 6x, and then plus 24. All right, so we think x could be 4 is a possible solution. So I'm going to put 4 as my box number. And then we have 3, 2, 1, 0, not missing any terms. So 1, negative 4, negative 6, and 24. Draw a line, bring my first term straight down. 4 times 1 is 4, combine 0. 4 times 0 is 0, combine negative 6. 4 times negative 6, negative 24, we get 0. So 4 is a 0, it works. Now remember, this was cubed, drop your degree by 1, so this is squared. So I have 1x squared, 0x minus 6. And then we're going to set that equal to 0 and solve for x. So I'm going to add 6 to both sides. So I have x squared equals 6. And then you solve by taking the square root on both sides. So we get x equals positive or negative square root of 6. So we get one real 0, and the other one is 4. And this is why we do the squaring it or the properties once we get here, because they may not be rational. And the theorem is only giving you the possible rational zeros. So like a half, anything that can be put in fraction form are the ones that are possible, not necessarily that they will work every time. But if it is rational, it would be one of those. However, sometimes it's not rational, like this. And you could do synthetic division all day and try those numbers, and you'll never find these numbers until you do quadratic formula or some other solving method once you get down to a square. So 4, and then we have square root of 6, and then we have the negative square root of 6. All right, so we're going to do the same thing with number 6. We're going to graph this, get close to some roots, and then we'll do synthetic division. And then once we do synthetic division, we'll use another method to find the others. So negative 5 plus x cubed minus x plus 5x squared. Uh-oh, I got it all at the top. I gotta fix that. X raised to the third. Got an arrow over to get down. And then minus x. And then plus 5x squared. There we go. That looks better. I'm going to graph. All right, so it looks like whole numbers all the way around. 1, -1, 2, -3, -4, -5. So 1, -1, -5 is what it looks like here. So number 6. Let me write this down in order. We have x cubed, and it is positive. And then the x squared term is positive, so plus 5x squared. And then minus x, and then minus 5. All right, so what it looks like, 1, -1, and -5. We're going to try -5. Doesn't really matter which one you do. We'll try -5. Since they're all whole numbers, I can just go ahead and do synthetic with all of them, just to save a little bit of time. So 3, 2, 1, 0, not missing any terms. So we have a 1, 5, -1, -5. Bring the first number straight down. Multiply -5 times 1, -5. Combine 0. -5 times 0, 0. Combine -1. -5 times -1, positive 5, get 0. So this guy works. Let's continue on with 1 from here. So I'm going to put 1 in the box. First number straight down, 1. 1 times 1 is 1. Combine, we get 1. 1 times 1 is 1. Combine, we get 0. So positive 1 works. Now let's try -1. Draw a line, bring the first number straight down. -1 times 1, -1, combine 0. So last row is 0 on all of them. These are my zeros. They all work. So 1, -1, and -5.